Welcome to the deep dive. Today, we're blending into something really interesting, this idea of agents.
Mm-hmm.
You've probably seen large language models do some pretty amazing things, right? But agents, they seem to take it up a notch.
That's a good way to put it, yeah.
We're looking at these LLM-powered systems that can, well, handle complex tasks, multi-step things, kind of independently for you.
Exactly. And think about it like this. Traditional software, it helps streamline workflows, makes things more efficient for humans to do.
Right.
Agents, though, they are designed to actually execute those workflows themselves autonomously. It's quite a big shift in how we think about automation.
Okay, let's unpack that. When you say workflow, what are we really talking about? Can you give some, concrete examples?
Sure. A workflow is basically just a sequence of steps to get something done. So think about resolving a customer service issue from start to finish,
Huh?
or maybe booking travel arrangements, flights, hotels, the whole thing, or even generating a complex report that pulls data from different places.
Okay, so definitely not just your standard chatbot answering a simple question then.
No, not at all.
What really makes an agent an agent? What's the fundamental difference?
Yeah, that's the core question.
Yeah.
So your basic chatbot or maybe a sentiment classifier, they usually stop after providing information or doing a quick analysis.
Right.
Agents, they're orchestrators. They have the capability, the built-in logic to actually manage the entire execution of that workflow.
Mm-hmm.
That's the key. Control.
Control, okay. So what gives them that control? What are the, essential ingredients, the characteristics?
Well, fundamentally, there are two core things. First, an agent uses an LLM, a large language model, for its reasoning, for making decisions, managing the steps in the workflow.
Mm-hmm.
That includes knowing when a task is actually done, or importantly, spotting if something went wrong and trying to correct it.
Yeah.
It can even decide to pause and ask for help if it gets stuck.
Okay, so the LLM is the brain. What's the second thing?
The second part is access to tools. To actually do things, the agent needs to interact with the outside world.
Right.
So it needs tools. These are typically APIs, ways for computer programs to talk to each other, or maybe even ways to simulate using a computer interface if there's no API.
Oh.
And the agent can dynamically pick the right tool for the job at each step. But crucially, it operates within defined limits. These guardrails we'll definitely talk more about later.
Okay, so it's an LLM brain. It's got tools to interact, and it works kind of on its own, but with rules. That makes sense. So our mission today for this deep dive is really to get a handle on the practical side of building these things.
Exactly.
Based on best practices people are actually using.
That's the goal, to give you a solid foundation so you can start thinking strategically about how you might build and use agents yourself.
Okay, great. So we know what an agent is.
Mhm.
Now, the big question, when should you actually build one? Because it sounds like maybe more effort than typical automation.
It definitely can be.
Yeah.
Yeah, building agents, it requires a different way of thinking about how systems make decisions compared to, let's say, conventional automation that just follows strict rules. Agents really come into their own where those traditional rule-based systems start to struggle or just fall short.
You mentioned payment fraud earlier. How does that illustrate the difference? Could you walk us through that again?
Absolutely. So imagine a traditional fraud detection system. It works like a checklist, right?
Mm-hmm.
If a transaction hits certain triggers, maybe the amount is unusually high, or it's from a weird location, boom, it gets flagged. Very rigid.
Okay.
An LLM agent, though, it acts more like a human investigator. It looks at the bigger picture, the context,
Like what?
like the customer's past buying habits, the time of day, maybe subtle patterns in the transaction data that don't fit a simple rule. It can spot potential fraud, even if none of the classic red flags are tripped. It's that ability to handle nuance.
Ah, I see. So it's not just following a script, it's actually reasoning about the situation. Okay, so if someone's listening and thinking about their own workflows, what are the key signs that say, hey, maybe an agent is right for this?
Yeah, good question. I'd say there are three main criteria to look out for. First is complex decision-making.
Okay.
If your workflow involves a lot of judgment calls, situations with a lot of exceptions, or decisions that really depend on understanding the context, like think about approving a customer refund.
Right.
You need to weigh the reason they're asking, their history with you, the specific product maybe. That kind of nuanced judgment is a good fit for an agent.
Got it. Complex decisions. What's number two?
Second is having difficult to maintain rules. If you've got systems where the rule book is just ballooned over time, it's become super complex, tangled, maybe prone to errors, and updating it is a nightmare.
Mm-hmm.
An agent might offer a more flexible, adaptable way forward. Think about vendor security reviews the rules and standards change constantly. That's a classic case.
Okay, so if your rules are a mess, an agent might help. Makes sense. What's the third one?
And third, look for workflows with a heavy reliance on unstructured data.
Meaning things like text.
Exactly. If the process involves understanding natural language, like reading customer emails, support tickets, feedback forms, or analyzing documents,
Mm.
or even having a conversation, like processing an insurance claim based on how the customer describes the damage over the phone, an agent's ability to understand language is a huge advantage there.
Okay, so summarizing. Complexity in decisions, really tangled rules, and lots of text or conversation involved. Those are the big three signals.
That's a good summary, yeah.
So conversely, if you're looking at a workflow and it doesn't really tick those boxes,
Yeah.
maybe it's pretty straightforward, rule-based, should you just stick with a more traditional approach?
I'd strongly recommend it. Yeah.
Hmm.
You really need to validate the use case against these criteria.
Hmm.
Sometimes, honestly, a simpler deterministic solution, a script, a standard automation, is going to be faster, cheaper, and just more effective. Don't build an agent just because it's the new shiny thing if a basic script does the job perfectly well.
Good advice. Okay, so we know when to consider an agent. Now let's get into the how. What are the absolute core pieces you need to assemble? The building blocks.
Right. At the most fundamental level, an agent really boils down to three key components.
Okay.
First, there's the model. That's the LLM itself. The engine providing the reasoning, the decision-making smarts.
Brain.
The brain, exactly. Second, you need tools. These are the external functions, the APIs, that let the agent actually interact with other systems, gather information, or take actions in the world.
The hands and eyes.
Kinda, yeah. And third, you need instructions. These are the explicit guidelines, the rules of engagement, the guardrails that tell the agent how it should behave, what its goals are, what it should and shouldn't do.
Okay, model, tools, instructions. And I see you've got a little code snippet here using something called the OpenAI Agents SDK.
Yeah, that's just one example of a library that helps you put these pieces together. The Agents SDK provides a structure for defining these components. You can see there, defining an agent, giving it instructions, adding a tool like GetWeather. Right. But the core ideas, model, tools, instructions, they apply no matter what specific framework or library you might end up using.
Got it. Okay, let's dig into each of those. Starting with selecting your models. There are so many LLMs out there now. How do you even start choosing?
That's a huge consideration.
Yeah.
It's not one size fits all. Different models have different trade-offs, right? Between how complex a task they can handle, how fast they respond, the latency, and of course, how much they cost to run.
And you might use more than one.
Absolutely. Especially as we get into orchestration later, you might find it makes sense to use a mix of models within even a single workflow. You don't always need the biggest, most powerful model for every single step.
Ah, okay. Like a smaller, faster one for simple stuff.
Exactly. Maybe just understanding the user's initial request or pulling a simple piece of data, a faster, cheaper model might be totally sufficient. But then for a really complex decision point like that tricky refund approval, you might want to bring in a more capable, maybe slower and more expensive model to make sure you get the reasoning right.
So how do you figure out that mix? What's a good strategy?
Well, a really solid approach is to start your prototyping using the most capable model you have access to for all the steps.
Okay, go big first.
Yeah, establish a baseline, see what the absolute best performance looks like, what's possible when the model is not the limiting factor.
Right.
Then, once you have that benchmark, you can start experimenting. Swap in smaller, faster models for specific tasks and see how the performance changes. Does it hold up? Or does accuracy drop too much?
Ah, I see. So you know the ceiling first, then optimize down.
Exactly. It stops you from prematurely limiting what your agent can do and gives you a clear picture of the trade-offs for each step.
So the key principles are benchmark with the best, make sure your core accuracy is there with those top models, and then optimize for cost and speed by subbing in smaller models where you can get away with it.
Perfectly put. And critically, you need good evaluations of evil setup, objective ways to measure performance throughout this whole process.
Right, gotta measure it. Okay, let's move to defining tools. These are the agent's connection to the real world, you said. What's important here?
Tools are what make the agent useful beyond just talking. They let it actually do things. Use APIs to check databases, update records, send emails. And even for older systems that don't have nice modern APIs, there are ways, these computer-used models, that let an agent interact with graphical interfaces, almost like a person would.
Wow. Okay, so it can work with almost anything.
Potentially, yeah. The key is defining these tools clearly and in a standardized way.
Why standardized?
It makes them reusable. You can share tools between different agents. It makes the whole system much easier to maintain and scale up. If every tool is defined differently, it becomes a mess.
Hmm.
Good documentation, good testing for tools, it's vital.
Okay. What are the main kinds of tools we typically see?
We can sort of group them into three broad categories. First, you have data tools.
Okay.
Their job is to fetch information, to get context, like querying a database, looking up customer info in a CRM, reading text from a PDF, maybe doing a web search to find current information.
Okay, data gathering. What else?
Second, action tools.
Yeah.
These let the agent actually change things or interact outwardly. Sending that email, updating the database record, creating a support ticket, maybe handing off the conversation to a human.
Got it. Taking action. And the third?
The third is interesting, orchestration. Sometimes an agent itself can act as a tool for another agent.
Ah, like the manager idea you mentioned earlier.
Exactly. We'll dig into that pattern later. But yeah, one agent calling another specialized agent as if it were just another tool.
Fascinating. Okay, and you've got another code snippet showing how to give an agent tools.
Yeah, this one shows creating a simple search agent. We give it instructions to search the web and save results. Then we equip it with a web search tool and a save results function. You just list the tools you want the agent to have access to.
Seems straightforward enough, but I guess if you start adding lots and lots of tools to one agent, could that become a problem? It absolutely can, yeah. As the list of tools grows, managing the instructions and making sure the agent picks the right tool can get tricky. That's often a signal that maybe you should think about splitting the task across multiple, more focused agents.
Okay, good point. Let's talk about the third piece.
Yeah.
Configuring instructions. You said this is critical. How do you write good instructions for an LLM agent?
It's maybe the most critical part, honestly. Because LLMs can be so powerful, but they can also misunderstand or hallucinate if the instructions aren't clear. High-quality instructions reduce that ambiguity drastically. They improve the decision-making, lead to smoother runs, fewer errors.
So, what are the best practices? How do you write instructions that work?
Okay, few key things. First, use existing documents if you have them.
Like SOPs.
Exactly. Standard operating procedures, support center scripts, policy documents. If you already have guidelines for how humans should do the task, start there. Adapt that for the LLM. For customer service, maybe each article in your help center becomes a potential routine for the agent.
That makes sense. Leverage what you already have. What's next? Second, prompt the agent to break tasks down. If you have a really dense document or a complex procedure, don't just throw the whole thing at the agent. Instruct it, guide it, to extract smaller, more manageable steps from that source material. It helps the model process and follow along much more reliably.
So micro steps almost.
Kind of. Third, define clear actions. Every step in the instructions should map to a specific, concrete action the agent can take, or a specific output it should produce.
For instance,
Instead of just saying, get customer details, be more specific. Ask the user for their account number, or use the Get Customer API tool with the provided email address. Be explicit. Even specify the exact wording for messages back to the user if needed. Less ambiguity is always better.
okay, precision is key. What else?
Fourth, try to capture edge cases. Real workflows are messy, right?
Okay.
Things go wrong. Users ask weird questions.
Definitely.
Think about the common variations, the likely problems. Include instructions for how the agent should handle those, maybe conditional steps. If the user doesn't provide X, then do Y instead. Anticipate the deviations.
Right. Plan for the unexpected. And you mentioned using advanced models to help write these instructions.
Yes, this is a really useful technique. You can actually use a powerful model like GPT-4o or even GPT 3.5 Turbo to take your existing human-readable documents, those SOPs or help articles, and automatically generate a first draft of agent instructions from them.
How does that work?
You basically prompt the model, telling it something like, you are an expert in writing clear instructions for LLM agents. Take the following document and convert it into a numbered list of unambiguous steps an agent should follow to complete the task described.
Wow, that could be a huge time saver.
You really can. Gives you a great starting point to then refine and build upon.
Fantastic. Okay, so we've got the core components, model, tools, instructions. Now let's talk about putting it all together. Orchestration.
Oh.
How do you make these agents actually run through a workflow effectively?
Right. Orchestration is about structuring how the tasks flow, how the agent or agents work together. And look, it can be tempting to jump right in and try to build something super complex and fully autonomous from day one.
Yeah, I can see that temptation.
But our experience, and what we generally recommend, is to start simpler. Take an incremental approach. It usually leads to more success in the long run.
Okay, crawl, walk, run.
Exactly. Broadly, we see two main categories for orchestration: single-agent systems and multi-agent systems. Let's start with the single-agent approach.
So this is where one agent does everything, just equipped with the right tools and instructions.
Pretty much, yeah. And a single agent can actually handle a surprising amount of complexity. You can start with a core task and just incrementally add more tools to expand its capabilities. This keeps the initial complexity down, makes it easier to test, easier to understand what's going on. You add tools one by one rather than immediately jumping into coordinating multiple different agents.
You mentioned the idea of a run before. Can you explain that loop for a single agent?
Sure. A run is essentially the agent's execution cycle. It takes an input, like a user message. It uses the LLM. It might decide to use a tool. It gets the tool's result back. It thinks again. And this loop continues until some exit condition is met. Maybe the agent calls a tool that gives the final answer. Or maybe the LLM itself generates the final response directly. Or perhaps it hits an error it can't recover from. Or it reaches a maximum number of steps you've set to prevent infinite loops.
And the agent's SDK has a way to manage this loop.
Yep, typically through something like a runner.run method.
Yeah.
You give it the agent and the starting message, and it handles that cycle called the LLM. Execute tools, feed results back until an exit condition is met. The example shows running an agent with a simple question.
So that loop is really the heart of how the agent operates. You also mentioned prompt templates for single agents.
Ah, yes. Prompt templates are super useful, especially as a single agent gets more sophisticated. Instead of writing dozens of slightly different prompts for every situation,
Right.
you create one flexible base prompt. And you use variables within that template to customize it for the specific interaction. The call center example shows this. Well, you have placeholders for the user's name, how long they've been a customer, maybe common issues they have.
Ah, I see. So one template, but it adapts using dynamic data. That simplifies things.
Hugely. Makes it much easier to manage and evaluate the prompts. So when do you need more than one agent? When does the single agent approach start to break down?
Yeah, what are the signs?
Well, again, we suggest pushing the single agent model as far as it can reasonably go first. Adding more agents adds coordination overhead.
Okay.
But if you find your instructions are becoming incredibly complex, like really long with tons of conditional logic.
It's then else nightmares.
Exactly. Or if the agent is consistently struggling to pick the correct tool from a large set of available tools, especially if some tools are quite similar, those are strong indicators that it might be time to split the responsibilities across multiple agents.
Okay, so what are the guidelines for splitting? How do you decide where to draw the lines?
Two main triggers, really. One is that complex logic. If the prompt is just full of branching conditions, breaking those logical chunks into separate, specialized agents can make each one simpler and more reliable. The other is tool overload.
Too many tools.
Yeah, especially if tools have similar functions or names. If the agent keeps picking the wrong one, and just renaming or describing them better isn't cutting it, then splitting the tool set among different agents, each focused on a subset of tasks, can really help improve accuracy.
Divide and conquer based on logic complexity or tool confusion. Got it. Okay, let's move on to multi-agent systems. This is where you have multiple agents working together.
Right, and here the workflow execution is distributed. We see two main patterns emerge quite often: the manager pattern and the decentralized pattern.
Okay, let's take the manager pattern first. What does that look like?
Think of an orchestra conductor. You have one central manager agent. Its main job is to understand the overall goal and coordinate other more specialized agents.
How does it coordinate them?
It calls them as tools. So the manager agent has access to other agents, but it treats them just like any other tool in its toolkit.
Okay.
This pattern works really well when you need a single point of control, maybe for handling all the user interaction, and then intelligently delegating specific subtasks to the specialists. The manager figures out who needs to do what, calls them, gets the results back, maybe synthesizes them, and then continues the workflow or responds to the user.
So the user mainly talks to the manager?
Typically, yes. The manager shields the user from the complexity of all the specialized agents working behind the scenes. The translation example is perfect for this.
Remind me about it.
If a user asks, translate hello into Spanish, French, and Italian, the manager agent wouldn't try to do all three itself. It would recognize the need for specific language translations. So it would call it Spanish agent tool, then it's French agent tool, then it's Italian agent tool. Get the results from each and combine them into one response for the user.
Neat. And the code example shows setting this up.
Yeah, it shows defining a manager agent instructed to use translation tools. Then you make these Spanish agent, French agent, etc. available as tools to that manager. The runner then handles the manager, calling these other agents when needed.
You mentioned some frameworks need a predefined graph for this, but the agent's SDK is more flexible.
That's an important point. Some systems are very declarative. You have to map out every possible interaction path in advance, often visually like a graph. That can be clear for simple flows, but gets really hard to manage for complex, dynamic ones.
Right.
The agent's SDK is more code first. You define the logic using Python code, which gives you a lot more flexibility to handle dynamic routing and complex conditional logic without having to pre-specify every single possibility in a rigid graph structure.
Okay, flexibility is key there. Now, what about the other pattern, the decentralized pattern? How's that different?
In the decentralized pattern, you don't have that central manager orchestrating everything. Instead, you have agents that are more like peers. They can directly hand off the entire workflow execution to another agent.
A handoff, like passing the baton.
Exactly like passing the baton. It's usually a one-way transfer. In the agent's SDK, this handoff is actually implemented as a special kind of tool or function call.
Okay.
When agent A calls the handoff function for agent B takes over completely. It gets the current state of the conversation and just continues from there. Agent A typically steps out of the picture at that point.
So when would you use this instead of the manager pattern?
It's great for scenarios where you don't need that central coordination or synthesis, where one specialized agent can just take the whole task and run with it.
Like the customer service example you had.
Perfect example. You might have an initial triage agent. Its only job is to figure out what the customer needs. Based on the query, it decides, okay, this is a technical support issue, so it calls the handoff function for the technical support agent. Or maybe it's a sales question, so it hands off to the sales assistant agent. The triage agent does its job, hands it off, and it's done. The specialist agent then handles the rest of the interaction with the customer directly.
So the first agent doesn't need to hang around.
Nope. It makes it very clean for things like conversation routing or situations where a specialist can fully own the problem once identified. Though, you can design it so the second agent could potentially hand back control if needed, but the core idea is that direct transfer.
Okay. Manager for central control, decentralized for peer-to-peer transfer. Got it. Powerful options.
Definitely. Choosing the right pattern depends entirely on the workflow's logic and needs.
All right. We've covered the agent's brain, its tools, its instructions, and how to orchestrate them. Now, a really critical piece, safety. You've mentioned guardrails a few times. Why are they so vital?
They're absolutely non-negotiable, really,
Yeah.
especially when agents can take actions or handle sensitive data. Guardrails are your safety net. They help manage risks, things like data privacy breaches, generating inappropriate content, going off topic, or even just making costly mistakes. They protect both the user and your organization's reputation.
And it's not just one thing, right? It's layered.
Exactly. You should think of guardrails as layers of defense. No single check is perfect.
Right.
So you combine different types, maybe some based on the LLM itself, some based on simple rules, maybe external services to create a more robust safety system overall. The diagram shows that idea of vetting inputs through multiple checks.
Okay. So what are the main types of guardrails people should be thinking about implementing?
There's a whole range. A common one is a relevance classifier. Basically, does the user's input actually relate to what the agent is supposed to do?
Like the Empire State Building question for a product support agent?
Precisely. Flagging that as off-topic.
Yeah.
Then there's a safety classifier looking for malicious inputs like prompt injection attempts, someone trying to trick the agent into revealing its underlying instructions or doing something harmful.
Okay. What else?
PII filters are crucial, preventing the agent from accidentally revealing or inappropriately requesting things like credit card numbers or social security numbers. Moderation APIs can check inputs and outputs for harmful content, hate speech, harassment, etc. You can also have tool safeguards. This means assessing the risk of each tool the agent can use. Is it low risk, like retrieving public data? Or high risk, like deleting records or transferring funds? High-risk tools might require extra checks or even human approval.
That makes sense. Any others?
Yeah, simple rules-based protections are still useful. Things like block lists for certain words, length limits on inputs, using regular expressions to catch known bad patterns. And finally, output validation, checking the agent's response before showing it to the user to make sure it aligns with brand voice and doesn't say anything problematic.
That's a lot of potential checks. If someone's just starting, where should they focus their guardrail building efforts first?
Good question. We usually recommend starting with the highest priorities. Data privacy, like PII filtering, and content safety, moderation, basic safety classification. Get those basics right first. Then as you run the agent and see where it fails or encounters weird edge cases in the real world, you can add more specific guardrails to address those observed problems. It's an iterative process, and you always have to balance security with user experience. Overly strict guardrails can make the agent feel useless.
It's a balancing act. Okay, the code example here shows a guardrail for churn detection. How does that work as a guardrail?
Yeah, this is an interesting example of using an agent as a guardrail. Here, before the main customer support agent processes a user message, an input guardrail runs. This guardrail is actually another agent, a specialized churn detection agent. It analyzes the user's message just to see if it sounds like they're unhappy and might leave.
Oh.
If that churn agent detects a high risk, the guardrail trips. It raises an exception, which stops the main support agent's normal flow. You can then trigger a different process, maybe escalate immediately to a specialized retention team.
Clever. So the guardrail intercepts the flow based on its own assessment.
Exactly. And the agent SDK handles guardrails like this quite nicely. They run alongside the main agent task, and if they detect an issue, they interrupt the process. You can build them as simple functions or, like here, as other agents.
Very cool. Okay, one last crucial safety point. Planning for human intervention. Seems unavoidable sometimes.
Absolutely essential. Look, no agent is perfect, especially early on. Planning for human intervention, having a human-in-the-loop strategy is vital. It lets you handle situations the agent can't gracefully without frustrating the user. And it's key for learning. Seeing where the agent fails helps you improve it.
So when should that handoff to a human happen? What are the triggers?
Two main categories of triggers. First, exceeding failure thresholds. You should set limits. How many times can the agent retry calling a tool? How many times can it fail to understand the user? If it hits those limits, it's stuck. Time to escalate to a human.
Right. Don't let it flail endlessly.
Exactly. Second trigger is high-risk actions. Anything sensitive, irreversible, or involving significant consequences like, say, deleting a user's account, processing a large refund, making a big configuration change. At least initially, these should probably require human review or approval before the agent proceeds.
Okay.
As you build confidence in the agent's reliability for specific high-risk tasks through testing and monitoring, you might gradually automate more. But starting with human oversight is the safe approach.
So set limits on failure and be cautious with high-stakes actions. That makes a lot of sense. Have that safety net.
Precisely. It's about ensuring there's always a way to gracefully handle situations the agent isn't ready for or shouldn't handle alone.
Well, this has been incredibly insightful, a real deep dive into agents. So just to wrap up the key takeaways. It feels like agents are a really big step up in automation, right? They let systems tackle complexity, use tools, manage these long workflows on their own.
Definitely. And they really shine in those areas we talked about: complex decisions, messy, unstructured data, those brittle old rule systems where simpler AI or automation just doesn't cut it. The autonomy is the game changer.
And building them reliably comes down to getting those foundations right. Choosing the right models, defining those tools clearly, and crafting really good, unambiguous instructions. And then structuring it well with the right orchestration pattern, single agent first, maybe multi-agent later.
Absolutely. Architecture matters. And layering on those guardrails from the start, thinking about relevance, safety, PII, tool risks, output validation that's critical for safe operation.
Plus, having that plan for human intervention, especially when you're starting out. Start small, test with users, learn and iterate. That seems to be the consistent advice.
That's the recipe for success, really. Don't try to boil the ocean on day one. Build incrementally, validate constantly, and you'll deliver real value and manage the risks effectively. The human in the loop isn't a failure. It's a smart strategy.
Great stuff. So if you listening are thinking about agents, exploring them, maybe getting ready to build your first one, hopefully this gives you a strong starting point. And there are definitely more resources out there, the OpenAI API docs, their business resources, lots to dig into.
For sure. And it all ties back to that broader mission, right? Using this powerful AI technology thoughtfully and beneficially.
Indeed. So maybe final thought to leave you with. As these agents become more capable, more integrated into how we work, how we live, How does that change our relationship with technology? What happens when we delegate not just simple tasks, but complex reasoning and action?
It's a fascinating question. Lots to think about there.
Definitely something to ponder. Thanks so much for joining us on this deep dive.